If you want to have a copy of this module, I've linked it in the description of this video. Lesson 3. The set of rational and irrational numbers. Before we move on to rational numbers, let's get the closure property of our integers, where you can add both integers and you still get an integer, get the product of integers and still get an integer, and get the difference, and it will always be an integer. But not so in the case of division. Sometimes you would get a whole number or an integer. Sometimes you won't. And we can call those rational numbers. So if we have, let's say, 5 divided by 2, you would get 5 over 2. And this is what you call a rational number. And this is where we will begin. Rational numbers can be in the form a over b. A and b are integers. There you go. But we have a restriction. We have an exclusion of 0 in our divisor because you can never divide by 0. If we get two integers, let's say 2 and 5, and we divide them, we have a rational numbers. And in the second here, a number which can be expressed in the form a over b. Every single integer can be expressed in this form. Let's take an example of 5. This can be expressed as 5 over 1. If we simplify 5 over 1, it is simply 5. But the important part is we've expressed it in the form a over b. Meaning, every single integer over 1, this is their fraction form. Every single integer then is a rational number. So if you're thinking integers, then you're just thinking of whole numbers, then so if you're thinking of just integers, then you're just thinking of whole numbers and their opposites. If you're thinking rational numbers, that includes integers plus the ones in between. Those are your 2/5, 5/8, and so on and so forth. Now we know the rational numbers are in fraction form. Let's go to the decimal form. When we go to the decimal form, you have terminating, non-terminating, and repeating decimals. When we say terminating decimals, it will end. It has an ending. Let's say 0.5. That's it. 0.1, 2, 3, 4, and it ended there, then it terminated. It has a last place number. Moving on from terminating, we have the opposite. Then let's go to non-terminating. Quite the opposite. It is a decimal that has non-terminating numbers. So if we have here pi, we have 3.14159265 and so on and so forth, and it doesn't end. So this is an example of non-terminating decimal that keeps on going forever. We have something similar here which is called repeating decimals. And like non-terminating, they won't terminate, but the numbers repeat. For example, we have here 1/3. If we put this in decimal form, it will be 0.33, and 3 would continue on. The difference of repeating and non-terminating is that non-terminating doesn't have repeating numbers. They don't have a pattern. In repeating numbers, you have a pattern, 0.123, 123, 123, and so on. So it does not terminate, but it's repeating. Let's finish this with an activity. Let's put the fraction form into decimal form. And remember, to go from fraction to decimal, just get the numerator and divide it by the denominator. Number 1, -1/4. Let's just get 1 and divide it by 4. Let's think about the sign later. How many 4s are there in 1? Well, there's none. So let's put 0 here. I'm going to add a decimal point here and a 0 here. How many 4s are there in 10? There's going to be 2. Because 2 times 4 is 8. So you will have 2 here. Let's add another 0. because we still have a remainder. And how many 4s are there in 20? There's going to be 5. 5 times 4 is 20. And we would get 0 for our remainder. So this would be getting the sign negative 0.25. Next, we have 3 over 10. Same thing. Get the numerator, divided it by the denominator. How many 3's are there in? How many 10's are there in 3? There's none. Then let's add 0. How many 3's are there in 30? There's going to be, and we have no more remainder. So this one is 0.3. Number 3, we have 3 and 500ths. Let's just get the numerator and denominator again. 5 divided by 100. Let's think about that whole number later. So how many hundreds are there in 5? There's none. Let's add a 0. How many hundreds are there in 50? There's none also. Let's add one more. How many hundreds are there in 500? There's going to be 5. And the remainder is 0. So this is getting the whole number 3.3 plus 3 plus 0.05. We will get 3.05. Number 4, we have 5 halves. Get the numerator and divide it by the denominator. How many 2's are there in 5? There's 2. So we have 4 here. Difference of 5 and 4 is 1. We have a remainder, so let's just add 0 here. Put that 0 down. How many 2's are there in 10? There's 5. So 5 times 2 is 10, and we have no more remainder. So this would be 2.5. Next, we have negative 2 and 1/5. Let's just ignore the sign and the whole number. Let's just concentrate on 1 divided by 5. Same procedure. How many 5's are there in 1? There's none. Let's add a 0. How many 5's are there in 10? There's 2. And we have no more remainder. So we're getting the sign, getting the whole number, plus adding 0.2 is negative 2.2. We have negative 1/2 here. Ignoring the sign, let's start first with 1 divided by 2. How many 2's are there in 1? There's 0. Adding a 0 here. How many 2's are there in 10? There's 5. With no remainder. So this is getting the sign, negative 0.5. Next, we have 3/20. Numerator divided by the denominator. How many 20's are there in 3? There's none. Add a 0. So how many 20's are there in 30? There's 1. So 1 times 20 is 20. So the difference of 30 and 20 is 10. And since we have a remainder, and how many 20's are there in 100? There's 5. So 5 times 20 is 100. And we have no more. And 3/20 in decimal form is 0.15. There you go. Number 8, 15 over 20. Let's just ignore the 3 for a while. Let's just get the numerator and divide it by the denominator. How many 20's are there in 15? There's none. Let's add a 0 there. So how many 20's are there in 150? There's 7. Because 7 times 20 is 140. And we would have the difference of 150 and 140 is 10. We still have a remainder, so let's add one more 0. And this is going to be 100. How many 20's are there in 100? There's going to be 5. So 5 times 20 is 100. And we have no more. This means our answer for this is, let's get the 3. Number 9, we have negative 5.5. 5 halves. Number 9, we have negative 5 halves. So we'll just get the numerator, divided it by the denominator. Let's just think about the sign later. How many 2's are there in 5? There's 2. 2 times 2 is 4. we have a remainder of 1 here. So let's add 0 here. And how many 2's are there in 10? There's 5. So the answer here is negative 2.5. There you go. Lastly, we have number 10, negative 2 and 4/5. So we have 4 divided by 5. Let's have the negative 2 later. How many 5's are there in 4? There's none. Let's add a 0. 5, not there, not the 0 there. How many 5's are there in 40? There's going to be 8. 8 times 5 is 40, and we have no more remainder. So this one is simply negative 2 plus 0.8. We have B, we have decimal numbers, then we're going to put it in fraction form. Okay, we have number 1 here, 1.8. 1 is a whole number, so you can just get that and put the fraction number here. And what you're going to do is get the number to the right of the decimal point, put it here, and depending how many they are, you're just going to add how many zeros also. Since there's 1, we're just going to add 1 0. And you're going to put it in the lowest term. So this is going to be 1 and 4/5. Let's do it here. We have negative 3.5. So this is going to be negative 3. We have 5 here. And there's only 1. And we're just going to put 1 0 here, which is 10. And we're going to put it in the lowest term, negative 3 and 1/2. We have here, number 3, negative 0.001. So we're just going to get the negative sign. And we're going to get how many is this? 1, 2, 3. 1, 2, 3. And that's how many zeros we're going to put. 1, 2, 3. So this is just 1,000. And we're going to get the lowest term. And this is just basically 1, negative 1 over 1,000. Next, we have 10.99. And this is going to be, let's get the whole number, 10. Let's put the 99 over here. And how many decimal numbers are there? There's 2. So we're just going to put 2 zeros here. And the lowest term is that. Now for repeating decimals, instead of tens, we're going to put it in nines. So we're just going to get the repeating number. So we have 0.333 here. So we know that it's just a repeating 3. So we know it's just a repeating 3. So let's just get that 3 over there. Over how many repeating numbers are there? There's only 1. So you're just going to put 1, 9. And get the lowest term, and this is going to be 1/3. Number 6, we have 1.5 here. So let's just get the whole number, get the 5. How many decimal places? It's just 1. So just going to put 1 0. Lowest term is 1.5. 1 and 1/2. Here we have 3 and we have 5. Just 1. And it's just going to be 3 and 1/2. Over here we have a negative, and we have 0, 0, 0, 1. 1, 1, 2, 3, 4. And this is going to be negative 1 and 10,000. This is not a repeating decimal since it terminated. So let's just get 10. And how many 9's are there? 1, 2, 3, 4. So we're just going to put 1, 2, 3, 4. And I believe this is already the lowest term. Number 10. We have a repeating 2 numbers here, which is 1, 3, 1, 3, 1, 3. So we're going to get that 1, 3. How many? There's 2. So 1, 2, 13 over 99. And I believe that's already the lowest term. That's it. End.